let's consider the pH and the buffer. So let's start with the pH. What exactly is the pH? So pH simply means the measure of the concentration of hydrogen ions in a solution. So you can calculate pH using the formula. pH is equal to the negative log of hydrogen ions. You can also calculate the pH using this formula, which is pKa plus log of the conjugate base over the weak acid. So now pH, when you combine pH and the pOH, you can get the value of 14. So pH plus pOH can give you 14. And from this equation, you can also calculate the pH, where you make pH the subject of the formula. So this can be pH is equal to 14 minus pOH. So these formulas, the first one is this one, second it's this, and the third it's this. So these three formulas can help you to find the pH of a solution. So what does the solution tells us when there is high pH? When we calculate and we find that the pH is greater than 7, what does that solution tells you? It tells that the solution is basic or alkaline. The pH, if it is less than 7, the solution, that's when it can be acidic solution. So measuring the pH, it can tell whether the solution is acidic or basic. So now we can also find the pOH using the same formula that is similar to the pH. So pOH we can calculate as negative log, then hydroxide ion. This is hydroxide ion. It is a negatively charged ion. So pOH is simply means the measure of hydroxide ions in a solution. Yeah. So now, how can you tell if the solution is neutral or not? For you to know if the solution is neutral, acidic or not, you also need to assess the amount of hydroxide and the hydrogen ions. You need to see the hydroxide and the hydrogen ion concentration in a solution. So now, how do you assess the hydrogen and also the hydroxide ion in a solution? Well, we need to use the ionization constant of water. What is the ionization constant of water? The ionization constant of water, it is denoted by Kw. It is the constant value, which gives 1.0 times 10 to the power negative 14. This is the ionization constant of water. So using the Kw, we can find the hydrogen ions or the hydroxide ions in a solution. This is the constant value. You just have to master it, so that even if a question comes, you need just to plug in this value in order to find the hydroxide ion if the hydrogen ion is given, or to find the hydrogen ions if the hydroxide ion is given. So now, what is the formula associated with this ionization constant of water? So ionization constant of water, it is given by the product of hydrogen ion and the hydroxide ion. This is how you can calculate. This means that if we have the value for hydrogen ion, we can easily calculate the hydroxide ion. Bear in mind that this is constant. So whenever you have been given hydroxide ion, then you have been asked to find the hydrogen ions, just make sure you plug in this where there is Kw, which is the ionization constant of water. What you need to know is that the neutral water, it has got the equal number of ions, the equal number of both hydrogen ions and the hydroxide ions. So neutral water has the equal concentration of concentration of hydrogen ion and hydroxide ion. What is that value? It is 0.0 times 10 to the power negative 7. So this, when you multiply them, let's say Kw is equal to this is the formula. So now, since we are saying that the neutral water has the same value of hydrogen ions and also the hydroxide ions, this simply means that when you multiply these two, this value twice, so the 1.0 times 10 to the power negative 7 times 1.0 times 10 to the power negative 7. So when you multiply, you get 1.0 times 10 to the power negative 14. So this is where the value of Kw is coming from. So okay, now let's just consider the Addison-Ausbach equation. So this Addison-Ausbach equation, okay, it is the equation that describes the dissociation of the weak acid into a conjugate base. So this Ausbach equation, Addison-Ausbach equation, it describes the dissociation of the weak acid into the weak base. So just like we have written it earlier, it is given as this is the Addison equation. It simply describes the dissociation of the weak acid to form a conjugate base, and this is the conjugate base and this is the weak acid. So using this equation, we can use it to find the pH when we have the pKa value and also the value for the conjugate base and also the weak acid. So now the pKa, it is the negative log of the Ka, the negative log of the Ka. Buffer system. What really is buffer system? Buffer system simply means any solution that resists the change in the pH of the body. So in the body, there are actually 3 biological buffer systems. One is proteins, 2 we have got bicarbonate, carbonates, and phosphate. These are the 3 main buffer systems in the body. So basically, proteins, they maintain the buffer system of the cells and also the blood. So for the protein, it's the cells and also blood plasma. It maintains the pH of the cells and the blood plasma. Then bicarbonates, it maintains the pH of the blood plasma. Then phosphates, it maintains the pH of the cells, intracellular component of the cells. So these are the main buffer system of the body. So now, how does the buffer work? Buffers are made up of the weak acid and a conjugate base. What does this simply tell? It simply tells that when there is an addition of the small amount of base in our body, that small amount of base can change the pH of the body. And when the pH of the body changes, it means that it can disturb the normal function of the enzyme. As a result, the buffer system, since it is the base that is added, the conjugate acid neutralizes this base in order to bring the pH of the body to normal. Also, when the small amount of acid is added to the body, the conjugate base neutralizes this amount of acid that has been added, so that it can maintain the body to its normal pH. Where you're not understanding, pause the video or rewind it to watch it again so that you can get the concept. In the next video, we're going to consider now the calculations related to pH. So just make sure you watch the following video so that you can get the full concept. Thank you.